Okay, a little bit more on the helper videos. Problem 3 is exactly like problem 2 in that you do it the same way. The one thing that you need to be careful of is don't forget the box. Okay, you got to add together the water, the banana, the chocolate, and the box. So just to help get you started, you have 3 bottles of water. So 3 bottles of water plus you have 2 bananas plus how many chocolates? 2 bars of chocolates. 2 bars of chocolates. And it has to go into the box. So you have 1 box. I already used the letter B for bananas. What should we use for box? I'll use a capital L for like lunchbox. How's that? Okay, so you have all of this. What is the probability that the entire food parcel weighs more than 1.5 kilograms? Okay, the other thing that you need to watch out for on here is that they give you the water, the bananas, the chocolate, and the box itself in grams, but they're asking you what's the probability that it weighs more than 1.5 kilograms. So the easiest thing is to convert the kilograms to grams rather than trying to convert these to kilograms. So 1.5 kilograms is 1,500 grams. Okay, so, and then you do it just like you did problem number 3. All right, so I'm going to move on to problem number 4. Problem number 4, we have a Poisson distribution. So we have, let's take a look at this. Saida collects data to investigate her email, finds that the probability that in a 24-hour period she receives more than 40 emails. Find the probability that in a 24-hour period she receives more than 40 emails. Okay, so my probability that I'm going to be looking for, the probability of my random variable is going to be greater than 40 emails, assuming that emails arrive independently of each other at these constant rates. Junk mail, she receives 1.5 per hour. And personal emails, she gets 2 per day. Ooh, 2 per day. Okay, so the problem we have here is that our time periods are not the same. So we want to make these time periods the same. So just like up here, these were all given to you in grams, and the total weight was given to you in kilograms. So I had to make the units the same. So I changed the kilograms to grams. So here, same idea, I want to make these in the same unit. If I change 2 per day to how many per hour, I'm going to end up with a decimal. So I'd rather go the other way. I'm going to change this one to how many pieces of junk mail per day. Okay, so there's 24 hours in a day. So if I do 24 hours per day, and I multiply that by 1.5 hours, then I'm going to end up, 1.5 per hour. 1.5 emails per hour. That's better. Now, if I multiply that together, my hours are going to cancel out, and I'm going to be left with emails per day. Okay, so which is what this is, emails per day. So 24 times 1.5 is 36. So this gives me 36 emails per day. So now I have the same time period here. So I've got the same time period for my personal emails and for my junk emails. And so now I can do my, this is going to be a Poisson distribution. Oh, it doesn't even say that on here, does it? So, but remember, we use Poisson when we have a time period. So whenever we see something happening within a time period, we're going to be using the Poisson distribution. All right, so my lambda, I have 2 Poisson distributions. One is the 36 emails per day. So my average number of junk emails is 36 per day. And my other one is my personal emails, I get 2 per day. That sounds about right. So we are going to add these together. So when we add them together, it's really simple. All we got to do is add them together. So my new lambda is going to be 36 plus 2 is 38. And so my variable, let's go ahead and set this up. So my random variable is distributed on a Poisson distribution because it's an average during a time period with a lambda of 38. I want to find what is the probability that this will be, what did I say, greater than 40. Greater than 40. Okay, with the Poisson, we have to do, it only gives us a less than. So we need to set this up. We're going to have to make this 1 minus the complement. So I wanted it to be greater, more than 40. So this is going to be less than or equal to 40. And if I subtract that from 1, I should be left with my probability of getting greater than 40. So then I just need to put that into my calculator. Let's see if we get it. Okay, so here we go into the calculator. I want 1 minus then my distribution, and it's going to be Poisson cumulative. Where is it? There it is. My lambda is 38, and my x value is 40. And I get my answer 0.334. 0.334. So my answer is 0.334. So I have about a third of a chance. My probability is about 33 1/3% that I will have more than 40 emails in a 24-hour period. And there it is. That's number 4.